My name is Queenet Onka. I'm a food scientist, and I'm currently a master's student at the Federal University of Technology, Mina. I hope everyone can hear me. Can everyone
Yes,
hear me?
yes, we can hear you.
Okay,
We
and
can
for
hear
today,
you.
all right. So today I will be your moderator for this program. Welcome to the Our Ladies Abuja Meetup, which is a program organized by the Our Ladies Abuja, a subset of Our Ladies Consortium. So, quick one before we go into the meeting properly. We have some housekeeping rules that I would want or urge us to follow so as to make the program interesting and orderly. So number one is we want everyone who is logging in to mute their mic to avoid distraction. We also want participants to drop their questions and answers, questions in the comment section, the Q&A session, that is the chat box. And then we also want the participants to, like I said, mute your mic when you're joining to avoid distraction, because this session is recorded. So these are the rules for now. Okay, I also want participants to engage with other participants respectfully. So welcome to the meeting officially. This meetup today is proudly organized by the Our Ladies Abuja organizers. Number one on the list, we have Bilkisu Olatunji, who is a data scientist. My humble self, Queenet, I'm a food scientist and technologist. We have Zinatuddin, sorry if I murder your name. Zinatuddin Mohammed is a public health analyst. We have Ifeoma Egbogah, a seasoned epidemiologist. We have Mabel Ajumobi, an epidemiologist as well. Abiodun Eguwenu, an epidemiologist as well. This house is filled with epidemiologists. So we have last on the list, Sikak Udo, a big data analyst. So today we'll be looking at modeling, turning conversation into strategy, and it will be handled by our guest speaker, a seasoned epidemiologist. She wears a lot of hats on her head in the person of Ifeoma Oti Egbogah. So we want to look at how to turn conversation into strategy and explore how unstructured text such as consumer feedback, social media discussions, call center transcripts, or survey responses can be analyzed to reveal recurring themes and priorities. And we'll be applying tools like latent dirichlet, dirichlet allocation, that is the LDE organizations that can detect trends, identify pain points, and prioritize actions. This sessions promises to be interesting and practical, and we won't waste much of your time. So, who is our special guest speaker? Like I said earlier, she's a seasoned epidemiologist and wears so many hats on her head. Her name is Ifeoma Oti. She's a zoologist and an epidemiologist with degrees from the University of Benin and Imperial College London. She is the co-founder and lead data scientist at Zilla Limited, a logistics and international shipping company where she uses data to improve operations. She also teaches an online course on data science with R with an aim to make data and tech more accessible to Africans worldwide. She's an advocate for women in tech, serving on our own R Ladies Abuja organizing committee, and she promotes gender diversity in the R program community. In addition to all that I have mentioned, she's a children's author with a series of coloring books focused on creativity and cultural identity. On this note, we welcome Mrs. Ifeoma Egbogah as she delve into this series. I hope we all give her our undivided attention. Thank you for joining us today.
Thank you and good evening, everyone. Thank you, Queenette. It's a pleasure to be here. I hope we can all hear me. Sorry, I have to turn off my camera because of the bandwidth of my internet. Well, it's good to be here and to take us on this topic, topic modeling. So without wasting much of our time, I'll just share my slides. Okay. I hope we can all see my screen. All right. So the rise of unstructured data, that's what we are going to be looking at and how we can use topic modeling. So, but before we start, we need to know what is unstructured data. You know, we have structured data, we have unstructured data. So structured data is data that has a fixed model or schema. It has a fixed plan. It has rows and it has columns. But unstructured data is something that's entirely different in that it doesn't have a fixed model or a fixed schema, you know. So basically we have things like your text, your pictures, your videos, all these, they don't come in rows and columns. So they are practically unstructured. They don't have really any format to it. But the thing is that this is still data. Whether it is structured or unstructured, it is data, and you're not meant to disregard it or consider it unimportant just because it does not have any structure. It's as important as your structured data, and that means that it contains information that can help us. Now we have analysts that have been trained so well in structured data, but what about the unstructured data? If you go anywhere to any company in any industry, you find that you have more of unstructured data than you do have for. Sorry about that. Can we all see my screen?
Yes, we can.
Yes, your is visible.
Okay, all right. So before I got cut off, I was explaining about structured and unstructured data. So for our unstructured data is rising faster than we have structured data in any industry we look at. You have industries where we now have videos, you have pictures, and you have customers leaving reviews, whether it's on the company's website or their social media handles on Twitter, Instagram, Facebook. All these are valuable information that can help any industry or any business. Then it needs to be analyzed. So we are going to be looking at how to do that, how to turn words into numbers. So today in this webinar, we'll be looking at understanding topic model.
the importance of topic modeling techniques, and implementation of topic modeling. Then we'll have a demo section where we'll see how we can do this in our So what is topic modeling? Topic modeling, the topics that are in our data, in our document. So we have our document. This document could be blog posts, it could be news articles, it could be journals, whatever document. And we want to identify themes or topics that are inside it. And this is what topic modeling helps us to achieve. So for us to proceed with topic modeling, we need to understand that our corpus is our document, and our documents can be our newspaper article and blog post. And how topic modeling works is that it finds the relationship between the words in the text and then put these words in clusters. Now, back then when we were in secondary school, in English, we'll be giving, during exams, you'll be giving a comprehension or a story to read. One of the questions that is being asked is, what is the topic or what is the theme in this comprehension? The teacher will ask you, identify the themes here. So what you do is you read it, and then based on words that you see you read from the story, you're able to tell what the story is about, the theme of the story. If you read a story, you may see words like, family, father, mother, children, and you say, okay, this story is about family. You could read the story. In that same story, you could see words like campaign, election, governor, and immediately draw out, okay, this is talking about politics, So these words, by grouping these words, you're able to get out the theme of the story. That's the way we answer. How we used to answer the question, the English questions. By picking out these keywords, you can say, okay, this story I read speaks on this topic. So that's the way topic modeling works. So why is it important? Why is topic modeling important to us? Why are we discussing it? Why now? So topic modeling is important because with it, we can uncover hidden themes. There are themes inside the story or the document. Like now, in a book club. In this book club, our book for this month is Thursday Murders, and we are all reading it. We expected that at the end of the month, we are going to discuss what we learned from the book, what we understood from the book, what the theme of the book. Now, for anytime this happens at the end of each month when we're discussing the book, what I see or what I drew, the insights I drew or the theme I saw is different from my fellow book club member. There was a book we read a couple of months back, A Kind of Madness, and I found that the way I saw the book was very different from the way someone else saw the book, and the stories and the insights they drew from were different from mine. But with topic modeling, we are able to avoid missed themes. It will help us to get all the themes that are inside our document. That's one importance of topic modeling. Another one is that it helps in information retrieval. So companies can arrange their documents or their information based on these themes. They're able to arrange it based on these themes. So if I come to a company and say, oh, I need information on damages, So based on that theme, the company is able to go into their archives and find everything that's related to damages. If it's something that has to do with delays, they're able to bring out all documents on delay. So that's what topic modeling can do for a business. It helps you in your information retrieval process and archiving as well. Another importance is that it helps in decision making. If we use topic modeling to analyze your customer reviews or your social media page, you're able to know what are customers talking about, what's their grievance, what's making them angry, what are their grievances. With that, you can make decisions on how to address what your customers are saying, because you need to keep your customers satisfied if you want your business to grow, and you need to know what are they talking about. Now, using this, you can then put each conversation, the conversation of your customers, into topics and then know how to address it. Another importance is in analysis, which is what we are going to do. It's really time consuming to read a whole document. Imagine a manual on how to operate an aeroplane. I can guarantee that it's highly voluminous, but with topic modeling, we're able to get out the topics in the manual. It helps us to be able to read faster, draw out things before we cannot decide, okay, I want to now read the entire book. With topic, you can decide, okay, this book is about this, okay, I need to read this section. So it helps in text analysis and helps us to read faster. Then it's good for research and discovery. There was a Tidy Tuesday challenge earlier this year. The data set was on about 5 or 6 journals. I can't remember how many now at this time. There are about 5 or 6 journals. And these journals, they had various articles over the years, So that was the data set. Now, you can use topic modeling in that kind of situation, in the sense that you can see what things have been researched on over the years and see how it has changed over time. With that, you can then decide, okay, this is the area I want to focus on. If you're in the academia, topic modeling can help you achieve that. And then customer experience. With topic modeling, you can improve customer experience because you get to address customer issues on time and effectively, because you know what you're discussing, you know what they're saying about you, you know what's going on. So you're able to address it on time, and then you keep your customers happy. Now, we're going to go into topic modeling techniques. We've been talking about topic modeling, so how do we do it? Now, for this particular webinar, for this section today, we are going to be looking at one technique. There are various techniques you could use, but this is the one we will use today. And that's the LDA, that's the latent dirichlet allocation. Now, if we look at the picture there, we can see that we have a document, and you can see that the document has various colors. Now, that tells you that this document has we have 4 colors, it has 4 topics in it. So this document is made up of 4 topics. And then we can see that words have been highlighted with different colors. You can see some words highlighted with yellow, some have been highlighted green, some of them light blue. Now, these are words that occur in a particular, you can find a particular topic. So basically, your document is made up of topics, and then you have every topic is now a mixture of words. So the LDA is basically, it's a Bayesian approach. It's a Bayesian approach. It deals with probability. So we're going to find the probability of those words in this topic, and then the probability of this particular document belonging to this topic. So that's the way the LDA works. Now, how do we carry out topic modeling in R? So we're going to look at the various steps before we begin with our demo session. So the first step is data preparation. Before you can start anything, you need data. So we need to collect our data. And for this particular exercise, we are going to be using a BBC News data. But then if you want to practice, there are other data sets you can find online. Inside R, there is a Taylor Swift package in R, where you can carry out topic modeling on the lyrics of her song. There's also a Tidy Tuesday challenge that had to do with Spice Girls. So you can go to the GitHub repo for Tidy Tuesday and check for the Spice Girl lyrics. You can do a topic modeling on their lyrics to see the theme of their songs. What are they singing over time? And then you have the Gutenberg package. It's also in R. This package is a collection of books, various books. You have the Sherlock Holmes books is there in this package. So you can look at it and find out themes being covered by each of those books. And then we have the Quantida package as well. So before anything, you need your data. Then the next step after you've collected your data is to pre-process it. Now, what is pre-processing? It's basically you have to tidy up and prepare your data for modeling. And the first thing we'll do is, because your data is a text data, so it's a made up of words, so we need to tokenize it. That's splitting your sentence into words. You split it into words. So basically, you put your data in a tidy format such that each word is in its own cell, because that's the principle of tidy data, that your variables are your columns, your observations are your rows, and then your values are in each cell. So we need to put each of our values in each cell. So that's the first step we'll do once you have gotten your data. And then you remove punctuation marks, numbers, remove the stop words. Once you've done that, you are now ready to use your data. So once you've done the pre-processing, then you now need to find your word counts. Once you've done the word counts, we need to create a document term matrix. A document term matrix. In R, we can use the cast sparse function. This function is in the tidy text package. So there, our rows now becomes our document, our columns are our words. So the matrix, what the matrix is going to do is that it's going to show the frequency of each words across all the documents. So that's what the document term matrix is going to look at, and that's what the cast sparse will also do for us. Then model fitting. Once you have your data, you've cleaned it up, tidied it up, and then you've put it in a matrix format, it's now ready for model fitting. And we can use the LDA function in the topic model package to do this. You now use it to create a topic model with the LDA package. After fitting our model, we've done that, we get our result. We can then visualize our result. We're going to look at two parameters from the result, which will be the beta and the gamma parameters we'll get. So with that, we'll visualize our result. And then you can interpret your result. You can then find the words that are called the most in each topic, and then your document, which topic is most talked about or prevalent in that document. So you interpret your result. So for this, the packages we'll use for this, we'll be using the tidyverse package, the tidy text, the topic models package. These are the packages we'll be using to carry out topic modeling in R. Excuse me. So we'll go over to R Studio so we'll see how we can do this in R. But before we do that, are there any questions so far? Any questions?
Please, does anyone have question? I can't see any question in the chat, but please, can you go ahead?
Okay, all right. So just give me a moment. I would need to share my screen, my R Studio.
Okay, sorry about that. Sorry about the delay. So we are in our studio now. We can begin. So let's read in our package that we'll be working with. We'll be using the library tidyverse package. We'll use library tidy text package. We'll use the library topic model package. Okay, so let's read in our data. Okay, so we have in our data. Let's look at it. This data is available online. I will share the link to the data so we can try out what we are doing. So this is our data. We have 3 columns. This is just an ID column. So we have the title, we have the description, and we have category. So title is basically the title of the news article, and then description, the story, that was written, published online. So for this BBC News data set, it's from 2004 to 2005. So, and it covered 5 major categories: business, entertainment, politics, sports, and technology. So the goal of this, our section today, is that we are going to apply topic modeling to uncover the hidden theme in this particular data set that we had, this particular story. What are they talking about? And then we will now analyze the text to reveal the topics that dominate the narrative as well. So as we have seen from the data set, we have our title, description, and then category. Now the category column is just a benchmark to evaluate the way our model discovered topics and to see how they align with the actual labeled categories, So first of all, we'll clean our data. Let's clean our data before we start. So I like to clean up the header names. So we use the janitor package to do that. Put it all in small letters or snake case where there are spaces. And then we can check if we have duplicates in our data set. If there are, we will need to remove them. So let's check if we have duplicates in our data set. So I can count the description because it's meant to be unique. So let's check, let's see if there's anyone that's more than one. So we have a couple, we have about 141. So we have some duplicates. So we're going to remove our duplicates. We'll remove the duplicates. Let's use the distinct function to remove the duplicates in our data set. And let's keep in one. Okay, so we've taken out the duplicates in our data set. And while I was explaining, I said we'll need to put our data in a tidy format, as in the pre-processing. So we are going to make sure that each of the description, each word in our description is in its own cell. So we are going to use the function on next token from the tidy text. So on next token function to achieve this. So word, sorry, and then description. Then we can count our word. Okay. Let's just unnest this and take a look at it. Oh, sorry. I think I already the tidy text package. Yeah, I did. Okay. So let's look at the next thing so we can see what it looks like. It's taking a while to come up. Well, because we have a lot of rows. Okay. Okay, so basically when we unnest, it's going to put each of the word in the description in its own row. We have over 400,000 rows. I think I have to stop this because it's taking a while to come up. Okay. So, but we can see that here in the console where it was. So we can see that here where we have our title, the category, and each of the words. So each of the words have been nested. India is now in its own column. This should be, I think, attend or attention. Then G7, meet 7, lead. So each word is now in its own column. Okay, let me stop that. All right. So since we have that, we can decide to remove the stop words in our data set. Some prefer to leave the stop words in while they're doing the modeling because it does add a bit of information, or you can remove it if you feel that it doesn't do anything for you. Stop words like it, and, is, these are the words you use frequently. You can remove them or you can keep them in your data while you're doing your modeling, when you want to model, if you feel it adds a bit of information for you. But we are going to remove it in this analysis we are doing. We are going to remove the stop words before we proceed. So our clean data set, let's do it over again. The honest tokens. Word description, and then we do an anti-join to our stop words. So get stop words. So we remove the stop words, and then we count our words. How many do we have? So we count our words, and we can sort this out, our words. So let's see the most frequent words in our data set. Sorry, words, not words. All right, so we have Mr. occurring 2,799 times. We have ye. We have also people, new, us, one, game, say, use. So these are the top most frequent words in this data set. So now that we have it, we've removed our stop words. Sometimes your stop words can be the one that occurs frequently in your data set because we use it anytime we are talking or writing. But since we've removed it, these are the frequently occurring words in this particular news article. So since we do have a lot of words, over 24,000 here, we're going to take words that occur more than 3 times. This will help our model perform better. So we're going to filter down our words. We need words that occur more than 3 times. You don't want words that occur only once or twice. It may not really give that much information. So we'll filter those ones out and work with words that are more than 3 times in our data set. And then we can now create a document term matrix using the cast sparse function. So with our cast sparse, we want the title. And words. So get a look at, see, sorry. Okay. So let's give that a run so we can see that. So this is our matrix here. Let me widen it a bit so we can take a look at it. So we can see for this one, UK needs tax court stories insist. There is 4 here. All these dots basically mean 0. So we have our document as a matrix. So let's save this. We're going to use it for our modeling. Let's give it a name, assign it a name. This is our matrix. So in this our matrix, we have our rows and we have our different tokens which we are going to use for our modeling. We can look at the dimension to know how many we have. Can just do dim. So we have 1,967 and then 3,458. That's our dimension. So we have 1,967 titles. That's our document, and our different tokens, our different words are about 3,000. So now we are ready. Our data set has been pre-processed. We've cleaned it, tidied it up. Now we can do our topic modeling on it. So we're going to be using the LDA to do this. So our data is the BBC sparse we are working with. And then now the thing about topic modeling with the LDA is that it won't tell you the number of topics at first. So you are going to have to try different number of topics. Now, depending on the documents you have, you may try to try 2 topics. You check, see the results, you get 3, 4, 5, 6. You try a number of topics. and then you analyze the result. From the results, you can then tell, okay, my data actually has this number of topics, or you could use what is called the perplexity approach to analyze the results from each of the topics to now determine the number of topics that suits your document. So for this our data, we're going to be working with 5 topics. We're going to say, okay, this particular document has 5 topics in it, and what are the words associated with these topics. So your K basically is the hyperparameter about the number of topics you think your document have. So before we do this, because anytime you do this, my topic number 1 could be very different from your topic number 1. We are going to set seed so that we basically kind of get the same result if you are following along. So we set seed before we run our model, so that as you run it with me, if you're following, you could get exactly the same thing I am getting. So our method is gives we're using. And then let's run this. Okay. It's running. So while this is running, the results from the model we just ran, we can then exploit. You can use the tidy function to look at your results. Basically, we're going to be looking at 2 probabilities, the beta or the beta probability and the gamma probability. So let's call this so using the tidy function to put it in a data frame result from our module, and we want to look at the beta probability. So our matrix is going to be beta. Yeah. So let's run that. And then let's have a quick look at the results. Okay. So from here, we have the topic, we have the term, we have the beta. So these topics from our model, we said, we think our data set has 5 topics. So then these are the words, the songs, this word song is in our data, is in our document. So it now tells us the probability of this word song being in this topic. So we can see this one, the probability is very low. Probability of song being topic 1 is very low. We can see that the probability of it being in song 2 is quite high. It's about that's 0.7%, whereas this one is really, really, really low. So this word song most likely is going to be in topic 2, but it's associated with topic 2. The word music, the probability of it being in topic 1 is very low. We can see that most likely this word music will be associated with the topic number 2, because it almost is about 3.04%, whereas for the other 3 topics, it's quite low. So this is what the beta probability tells us. The probability of this word being in this particular topic or being associated with this topic. Now we can visualize this, now that we have this, to see how the words are arranged for each topic and the probabilities. So let's do that quickly. We're using our ggplot to do that, to visualize the beta probabilities for each of the words. So we're going to group by topic. We'll group by topic. And then since we have a lot, let's just take the top 10, the top 10. Let's arrange it. Change the topic. Meeting. And then mutate to, so we can reorder within. Can reorder within 10 later and topic. Let's make a plot. Let's remove the legend. Need to do a facet wrap here. Facet wrap for the topic. Let's make the scales free. Okay, so we have our plot here. So let's look at it. So let's look at our plot. In our plot here, so we can see the 5 topics, 1, 2, 3, 4, 5, the 5 topics, because we said, okay, our document has 5 topics. We can see for topic 1, the probability of each of the words. So Mr. has a high probability. We have govern, labor, say, elect, party, tax, blur, brown, lord. So these are basically the top 10 words with high probability for topic 1. For topic 2, we have game, film, music, best, award, show, yay. Now, looking at this topic 1, I can say, okay, this looks like it's politics. Topic 1 has to do with politics based on the words here found in topic 1. Because you have labor, so it has to do like labor, the Labour Party. We have blur, which is basically the prime minister. Brown, so the prime minister. You have tax, you have elect. Looking at topic 2, we have game, film, music. So this tells me most likely it has to do with entertainment because I'm seeing award, show, you know. Now looking at topic 3, we have US, you have us, right? US, you have the year, we have bank, company, sale, market. So I can say, okay, this might be business because you're having economy, rate. So this topic has to do with business. And here we have England, world, new player, club, Wales. So this might be sports. Looking at player, club, England is basically sports, maybe even focused on the Premier League, you know. And then this one we have use people, mobile, phone service, technology, network system. So this might be news or words that had to do with technology. So this topic 5 is technology. So looking at this, I can say, okay, based on the way the words are arranged for each of the topics, I cannot say, oh, the theme for this document, I have themes on entertainment, I have themes that had to do with business, I have things that had to do with sports, some themes that are on technology, and some on politics. So using this topic modeling, I've been able to kind of arrange my documents into things that I can understand based on the words I've gotten from there. So the thing with topic modeling is that even when it gives you the words and the probabilities, you also need to use your human intuition to now say, okay, this is basically what these topics are all about. These words in these topics are all about, or they're addressing. Topic modeling is not going to tell me that number one is politics. It will just give me probability of the words belonging to this topic. It will not tell me that, okay, the name of this topic is politics. No, it won't do that. But it will just tell me that, okay, topic one has these words in it. So it's for you to use your human understanding and say, okay, these words have to do with politics. So that's what the beta probability shows us from our modeling. The results of the beta tells us the probability of each word in each of the topics. And putting it as a graph, you're able to visualize it and understand it better. Now you can increase your because here we just want the top words. You can increase it, make it 20, make it 50, and see other words that make up that particular topic if you want to. But then as you add more words, your graph may become unreadable if it's too much. But for now, we're just looking at the top 10. So let's look at the second result, or the second parameter we can get from our topic model, which is the gamma probability. So just like we did using the tidy function to get the beta, is the same way we would do that. So tidy, our model that we read, which was the LDA, and then the matrix we want is the gamma. So we can look at this. Let's look at the result. So from this result, it tells me what is the probability that this particular document belongs to this topic. So we have this document that says scissors, sisters, triumph at Brits. So the probability of it being in topic one is about 1%. But we have this one about the Kilroy launches varieties party, and the probability is quite high. We have seen a 0.7, almost 70%. So this one, probability of this document being topic one is really high compared to the other ones that we are seeing. We have also this one, terror powers, which is about 29%. So the gamma tells you the probability of each of the documents belonging to a particular topic. We can also see this in graphical forms to help us understand better our results. So we'll first of all, we'll join it to our data, that had our full data set. We'll join it there. So our clean data set and try to. So let's have this poly BBC join. Okay. So we've joined our data to our data set, to our original data set. We've joined our result to our original data set. So let's go by topic. So we have a box plot. It's telling us which topic our document is focused on, the most common topic or the most prevalent topic in our data set. So from this box plot, you can see we have more of topic 3 in our data set. The entire document talked about basically, this is like almost 20% of the entire document is based on topic 3 compared to the other topics. Though other topics we are getting maybe 18, 19% thereabout, but this one has a lot of our document, a lot of our articles is talking about topic 3. Many of the news articles are things that had to do with topic 3. That's what this distribution is showing us here about our model. That our model is saying that topic 3 is the most common topic talked about in this particular article we are reading. Okay. So going back, we can also check as well each of the description, each of the topics, and find out what the documents or article, and find out what topic do they fall under. So let's randomly select some topics from our data. Let's take about, let's say, sample some. So from our entire data set is over 2,000 something. We want 10 numbers. So I want 10 numbers from 1 to 2,020, 2,220 words, which is like basically the number of documents we have here. So just to pick randomly any words, any number, then this number, I'm going to use it when I'm plotting to say, okay, I want documents with this particular ID number, because in our data, we had a column that had to do with ID. So I want, if it's number 1, pull this out, and I want to know the topic. So this sampling is going to help me randomly pick 10 numbers, which I can then graph. That's what I'm trying to do here, to randomly pick out some topics, some documents or description in our data set, which I want to now see under what topic they fall in. So that's basically what I'm trying to show us here. So we have join data sets, and then I want to filter. So let's next. So because in our BBC data set, we had this column that had 0 to over 2,000 something. So randomly pick any of the numbers here, and let's see under what topic that particular article falls under. So I'm saying filter where X1, from these 10 numbers, pull it out for me. So I want to make a graph and see where it falls under. So go by topic. Just like what we did before, I want to put topic as a factor. Make a plot. Okay, we can run that. All right. So let's look at, okay. Let me make this on the x-axis instead. Okay. So this is a plot. These are different documents, about 10 that were just randomly picked when we ran that sample. So we can see this particular topic or title, Blair's hope for blanket return, tells us that, okay, this one belongs to topic 1. Because when we did the word probability, looking at our beta probability, we saw that we had words like Mr., blah, people, tax. That also is document. So this is telling us that this article with this title belongs to topic 1, and it had a probability of above 35, And then we have this Borussia Dortmund near bust, telling us that this document, this article, it's in topic 4. And if we remember from the beta probability for topic 4, we saw things like England, player, Wales, that all as sports. So our model is actually doing pretty well, able to categorize each of the articles to where they belong, to the topics that they belong to. Then we see this one, Castanede, I think that may be a claw, fires Laporte, topic 4, also had to do with sports, Now for this one, we can see Connors boost for British tennis. It's also telling us it's in topic 4, sports. Then we can see this one, musicians to tackle US red tape. It's telling us this particular story, this particular article is going to be in topic 3. Now, if you remember, our topic 3 had to do with things like awards and all that. So basically, it's entertainment, So with this in kind of topic modeling on your data, you are able to get the themes that are in your data. And then also, what's the probability of this particular article belonging to this theme, which is what Gamma is telling us. So right now, you can do it for the entire data set and see, okay, where this particular document, what topic does it fall under? And you can plot it and have a look. You can see the UK troops on Ivory Coast standby. You can see this one, the model is saying it belongs to topic 4. So this is what topic modeling does. It tells you your document is a mixture of topics, and each of these topics are mixtures of words. If you can find the distribution of the words, you can also get the distribution of the topics for your document. And then with that, you can then draw insights, and also find out what documents, what topic does it fall under. So another thing I would like for us to look at, though it's not just because we had in the data set, we had a column for category. You can just quickly look to see how well the data perform against the actual category from the data set. We saw that it had the data had a column for business, technology, sports, and politics. Let's see how well our model did. Just a quick look before we round up. How well did our model get the classification? Okay, so look at, let me go back to this plot so I can do that. Okay. So data set BBC join. So I'm going to create a new column to see how well. So case when topic equals one. Politics. So when it's topic 2, from our beta distribution, we saw, okay, topic 2 had to do with entertainment because we had game, film, music. So 2 is entertainment. And then topic 3. Topic 3 was had to do with business. Topic 4 was sports. Topic 5 was tech. So this, I'm getting this from beta probability, the graph that I did, where the bar plots we got here to arrange and say, okay, topic 1 is this, topic 2 is this, topic 3 is this. So let's see. So let's quickly look at this. So funny. So so before I do this, I'll need to want to read in the yardstick package to do it. I always want to do like a plot, a confusion matrix to see it, how well the model did. All right. Okay. I think there may be a mistake in my spelling somewhere. Yes. Okay, I think there's a mistake in my spelling. But anyway, we can try that out. I think I will have to stop here. Hello. Can you all hear me? Hello, can we all hear me?
Yes, we can hear you.
Okay. Sorry. So I think
it's a spell mistake in my spelling. That's why I'm getting this error. But I'll have to stop here because I know it's almost 6. So if there are any questions, I'm happy to take them now.
Okay, thank you, Mrs. Ifeoma, for such enlightened presentation. It was really in-depth and practical. Thank you very much. I don't know if our participants have any question. I'll put it in the chat box so that we'll react to it.
Yes, the recording will be posted online. I will also share the link to the slides and also the code. I'll share it with the organizers so you can, the codes I use in R so you can follow through. If at any point I was talking too fast and you missed any step, so the slides will be available online for you to follow through with the codes, and also links to different data set that you can try your hands on aside from this one we worked with today.
Okay, in the absence of any other question, thank you so much, Ifeoma, for this great exposition. So I would like for Bilkisu to give us any updates, if there will be any.
Okay, thank you so much, Queenette. That was a great session, Ifeoma. Thank you so much. We really had a wonderful time. So
Thank you.
so we're looking forward to another month. Hopefully, we'll be able to get more speakers to show up for us, and we'll still keep in touch. So for now, not really, nothing. Thank you.
Okay, thank you very much, everyone, for your time and for your patience and for observing our housekeeping rules. Links to this series will be shared online, and okay, someone is asking if someone wants to speak, can we do so? Present a topic in one of the months. Over to you, Bilkisu.
Okay, that really gladdens my heart. Yeah, we're welcome to have you. Whoever we want, even we're trying to make it localized, that we have more of our speakers from our local community. So if you're willing, you don't want to be so scared, it's not a perfect stage. So you're welcome to just get in touch with us. Then we'll be able to get you ready and we'll support you no matter what. So it can be as simple as even using dplyr, can be as simple as your experience using R. Even if it's 30 minutes, you're welcome to just come, show up, and support the community, share what you know, and we're here to support. Thank you so much.
All right. Thank you. So with this, I would we'll bring this session to a close till next month. I expect to see all of us here next month. Thank you for joining us, and have a good evening.
Thank you, everyone. Good evening, good night.